In this presentation, we're going to look at two metrics that are quite commonly used in medical statistics, but are equally applicable in other fields of statistics: sensitivity and specificity. So, consider a binary classification system. Now, in the case of medical statistics, this would probably be a diagnosis. We have a binary classification: healthy or sick. And the possible outcomes are, for example, true negative, that healthy people get correctly identified as healthy; true positive, sick people correctly diagnosed as ill; false negative, the sick people wrongly identified as healthy. That's an important one. And also false positives, healthy people wrongly diagnosed as ill. So you can imagine that the two second cases there will be of considerable concern to the medical profession. So we could tabulate our four outcomes in such a way. We have the actual classes, they're the healthy people and sick people, negative and positive, and the predictive classes, negative and positive. So diagnosis as sick or diagnosed as healthy, or vice versa. So, TN, FP, FN, and TP, those are the four building blocks. So, here we have them again. The key metrics are as follows: sensitivity, which is the total number of true positives out the proportion of true positives over total number of actual positives. Okay. And in some other fields of statistics, this would be actually known as recall. For example, accuracy, precision, and recall. That's one of my other presentations. So, recall and sensitivity are pretty much the same thing. So, in the other case, we have specificity, which is the total number of true negatives divided by that means that people who are predicted to be negative and are negative divided by the total number of uh, people who are healthy, the total number of actual negatives. Now, so we have 100,000 patients, let's say, and we have 97,000 patients, let's say, that are, according to some tests, are healthy and diagnosed as healthy. What we might be interested in here is that the total number of people who are predicted to be ill when in fact they're healthy. So that is the false positive. The total number of people, so that's 150. The total number of people who are actually ill but are considered to be healthy, 330. And the people who correctly identified as sick, 1,770, and so on. So, uh, accuracy is just going back to that. This is just a quick remark on the total number of correct classifications from the overall number of cases. In that last example, we had 1,770 correctly identified as sick and 97,750 correctly identified as healthy. Altogether, that meant that there was 99.52% correct diagnosis. But the other two metrics are more important. So let's first look at sensitivity, the proportion of correct positive classifications, true positives, from the cases that are actually positive. So the people who are diagnosed as ill, how many people are diagnosed as ill, given that they are ill. So it's the true positives divided by the total number of true positives and false negatives. That's the total number of people who are actually ill. So based on that last example, we had 1,770 people were diagnosed as ill, correctly diagnosed as ill, but we missed 330. That there was 330 people who were sick but not diagnosed as sick. Altogether, the total number of people who are actually sick is 2,100. So we are actually correctly diagnosing 84.28% of sick people as sick. That's not as impressive as the last score we got for accuracy. So we're only actually correctly identifying 84% here as of the sick people as sick, which is not as impressive, a bit worrying. Let's look at specificity as well. So this is the sort of the opposite case. We're looking at the total number of negatives. So this is actually proportion of correct, sorry, let's just say negative classification. So the true negatives from cases that are actually negative. So the specificity is the total number of true negatives divided by the total number of actual negatives. So there we have it again. So again, proportion of correct negative classifications, never mind that. And so we had 97,750 people who were healthy and diagnosed as healthy. Altogether, there was this many healthy people. So we had falsely identified 150 people who were actually healthy. We falsely diagnosed them as sick. So altogether, in this scenario, we have 97,900 healthy people. So altogether, we've correctly identified 99.84% of them, of the healthy people, as healthy. And that ends our presentation.